velocity, height, and energy, oh my. Hi guys, it's Nikita and Neelesh here, and we're going to talk about velocity, height, and energy and its relationships.
So we went to a local park to see the relationship between gravitational potential energy and kinetic energy. So on the swing, we set our reference 0 point to where the swings are. So as they set at rest, that's our 0 point.
Here you can see me calculating the height from the max height of where Neelesh went on his swing to the bottom, which was 3.05 meters.
Yeah, so as you can see, as I was on my swing, max height I reached was parallel to the top bar.
Now here, swings work by converting potential energy into kinetic energy. So when Neelesh was at the top, there was only potential energy and no kinetic energy. But as he swung down, the potential energy transferred to kinetic energy, and then at the bottom, there was no gravitational potential energy and only kinetic energy. Through the conservation of energy, we can see that the total energy was always conserved and neither created nor destroyed.
So if someone pushed me, then my kinetic energy would have increased. But since I was pumping my own legs and I was part of the system, I was increasing my potential energy. And as I swung my legs, I rose my overall center of mass. So I raised myself to my max height.
Now here we assume that there was no air resistance on the snowy day. The mass of Neelesh was 55.45 kilograms, and in the system included Neelesh, the swing, and Earth.
So here's a video of me on the swing.
Enjoy!
So we wanted to calculate my velocity. So what we did was we set our gravitational potential energy equation equal to our kinetic final. So this is because we had no kinetic energy to start with, so that's why on the left side it's just gravitational potential energy. And our ending reference point was when I was complete at 0, so when there was no height, and I was at my reference point, that's when we finished.
So the gravitational potential energy and the kinetic energy transfer back and forth in a swing motion while the total energy is conserved. That's why we set them equal to each other. So we have mgh is equal to mv squared over 2. We plugged in our mass, the acceleration due to the Earth, and the height, and we found the velocity to be 7.74 meters per second.
So we also took this a step further, and we tried to figure out the tension in the chains, or for this we can call it a rope. So what we did was we had to assume that I was traveling in a circular motion to use the equations that we know. So this red line shows what the path would be if I was traveling in circular motion. So we know that the radius of the circle, which is technically what the rope or chains are, was 3.05 meters.
So since we assumed that the path was perfectly circular and that the chain was also taut, we set our tension to equal mg plus mv squared over r. We got mv squared over r because acceleration is the sum of the forces over mass. And since we're doing circular motion, the acceleration is equal to v squared over r. Arranging the equations, we get mv squared over r plus mg. So we plugged in our numbers and we got 1,633.10 newtons.
So we took this a step further, and we tried to use this information of setting our gravitational potential energy equal to our kinetic energy, and we tried to see what my velocity would be if I traveled down a swing. I traveled down a slide.
Now in the slide, the system was the slide, Earth, and Neelesh.
What a beast.
So, energy here transferred from kinetic to potential energy. Potential energy was a stored energy. At the top of the slide, Neelesh had potential energy but no kinetic energy. But as he went down, it changed and he had more and more movement and less potential. Until at the bottom it was all movement and all kinetic energy and no gravitational potential energy. From the principle of conservation of energy, we know that the energy was neither created nor destroyed, and it was simply converted from one form to another.
So the difference in your potential energy and kinetic energy as you travel down the slide is lost in the form of thermal energy due to friction. But since we are assuming that there was no friction, there's technically no heat generated.
Now here we set our initial gravitational potential energy to equal the final kinetic energy. We first calculated the potential energy, which was mgh. Inputting our numbers, we found that the energy was 968.25 joules. Then we know that energy was conserved, so we then equal our kinetic energy formula to our gravitational potential energy formula.
So as we solved for that, we tried to find our velocity, which was equal to 5.90 meters per second.
And the kinetic energy was therefore equal to 965.11 joules.
So here's a video of me going down this slide.
Hope you enjoy it.
Thanks for watching.